Hi, welcome to Number Club. This is Year 1 Pure, Chapter 2, Lesson 2. And today we're going to be learning about a really important topic, which is completing the square. So let's get cracking. So these questions say, complete the square, give the turning point, solve if possible, and sketch. Now, each of these are quadratics. Quadratics will always be either U-shaped or N-shaped, depending on how y relates to x in terms of its sign. So if y equals positive x squared, some positive version, you'll get a U shape, and if y equals negative x squared, you'll get an N shape. Now, sometimes these will have solutions and sometimes they won't, but there are things that they will always have, which is a turning point. Completing the square can tell you about quadratics that the quadratic formula or the factorizing can't. If you have a quadratic that doesn't have any solutions, say it looks like this, it doesn't have any x-intercepts, doesn't cross the x-axis at all, these are called roots or solutions, then factorizing it is impossible. It's not going to work. Using the quadratic formula is impossible, not going to work, but completing the square can tell you something about that quadratic. It can tell you where that is, where the minimum is of that curve. It's called the turning point. This is called a minimum, okay? And there are also maximums where you've got N-shaped quadratics that look like that. Okay, so let's take a look at the first one. You should know a bit about this from lower down the school at GCSE, so this is just a recap. Things to do. You halve that. So we have brackets x plus 3. You halve your b coefficient with a squared. There are some things that are totally non-negotiable. That will happen, this will happen, and this will happen. You'll also always subtract the square. Okay, so it's square and subtract every single time. So the square of 3 is 9, so we'll be squaring and subtracting with the minus 16 on there as well. Y equals, by the way. So y equals x plus 3 all squared minus 25. That's fine. Okay, that is called the completed square form. If you are asked to give a question as the form y equals x plus a all squared plus b, that's fine. That's what this is. I know that says negative and this says positive. B is negative 25. Okay, don't worry about the sign on there. Okay, that is called the completed square form. The turning point is found when this bracket equals to 0 is your x coordinate. So the turning point is found. The opposite of this sign, you should only ever have x plus or minus a number in here. Okay, it shouldn't be 2x or 3x. If there's something like that, you've gone wrong. So the turning point is negative 3, because that's the opposite of this, okay, and this bit here, which is negative 25. That's the turning point of this graph. The turning point is negative 3, negative 25. Not too bad. Okay, so we've completed the square, we've given the turning point, and now we're going to come towards our solves. Now our solves happen when the graph equals 0. When is it that the graph equals 0? This is the graph. When is it that the graph equals 0? In other words, when is it that this graph crosses over the x-axis? Because when it crosses over the x-axis, the y-coordinate is 0, isn't it? Okay, so if we're finding solutions, we let y equal 0. This will become a 0. So what we'll actually be solving is going to be x plus 3 all squared minus 25 is equal to 0. X plus 3 all squared is equal to 25. X plus 3 is equal to the square root of 25, which is plus or minus 5. Look back into the previous video for a little bit of a hint about that. And so x will equal negative 3 plus or minus 5. When x just appears once with a quadratic, make it the subject. Okay, that was in the previous video as well. That will be a quicker way to find your solution and you won't have to mess around with it. Okay, and in this case, you wouldn't want to expand it back to a quadratic to only try to factorize it to realize it doesn't factorize. Okay, so we have this thing, well, in this case it does. We have this thing, we've got x is equal to negative 3 plus 5, which is 2, and x is equal to negative 3 minus 5, which is negative 8. The sketch, I'm running out of space here, we've got 2 and negative 8, those are our x-intercepts. All quadratics are always symmetrical. So because this is a greater distance away from 0, the quadratic has to be over on the left-hand side. Our turning point, that's -3, -25. And we also know our y-intercept, which was -16. Okay, that is all the information you could possibly know about that quadratic. It's a lot of information that we've managed to get out of something that was pretty simple to do. Okay, obviously it's a little bit messy because it's in a little bit of a strange order, but there we go. Okay, let's take a look at this question. This is more difficult because we have an odd central coefficient. Also, sometimes people think it's going to be a bit more difficult because there's a negative there. It's not. So we have y equals non-negotiable x. We're going to halve this, put it as 7/2. Don't put it as 3.5. If you want to put it as 3.5, feel free, but when you square it, it's going to be a little bit more difficult to deal with. Okay, squaring this is plus 49. Pardon me, it's minus 49/4. Okay, you can, if you want to, use a calculator and just go with 3.5 and 3.5 squared. If you really want to, it's 12.25, and that'll be absolutely fine. But for the most part, fractions work just as well. It's up to you. All right, on the next one, I'll do a decimal version just so you can see it. So we have this. The turning point is going to equal 7/2 and -49/4. The solutions, well, the solutions are going to be when this stuff equals 0. So we'll have x minus 7/2 all squared minus 49/4 is equal to 0. We'll have x minus 7/2 all squared is going to equal 49/4. We'll square root this. So we'll end up with x minus 7/2 is going to equal plus or minus 7/2. Okay, square root of 49 and square root of 4 are 7 and 2 respectively. And so we'll get x is equal to 7/2 plus or minus 7/2. One of the solutions is x equals 14/2, which is 7. And the other solution is where x equals 0. Okay, so we've managed to complete the square, find the turning point, find the solutions. The sketch, x equals 0, x equals 7. The turning point will be symmetrical. So there's my turning point, which was 7/2 and -49/4. You can give the decimal version if you want to. It should be 7/2 because 3.5 is halfway between 0 and 7. Remember, the turning point lies on the line of symmetry. So you could be asked, for example, give the line of symmetry. The line of symmetry is x equals 7/2. All right, I'll show you a decimal version with this question. So we have y is equal to x squared plus 3x plus 10. It's a little bit of a sneaky trick, just putting things on the wrong side, but it's not too bad. So we'll get y is equal to x plus 1.5 squared, subtract 2.25 plus 10, which means that x will equal, y equals x plus 1.5 squared plus 7.75. Okay, your turning point is going to be -1.5 and 7.75. The solutions, well, the solutions, in this case, I'm going to go a little bit quicker with it. What I'm going to do is I'm going to say, well, I'm going to have -7.75, and then I'm going to try to root that. Okay, I'll move it over and I'll try to root it. Can you root that? Does that root? Okay, does it root? Well, no. Okay, you cannot root a negative number. You can't produce that. So, as I mentioned at the start of the video, sometimes you can't solve these. Sometimes they don't have solutions. And the fact that this doesn't have a solution means that completing the square can tell us the only things we could know about it, which is we've got -1.5, 7.75 as your turning point. Okay, we know that it's U-shaped. We know that it's U-shaped because this is a positive x squared here. And we also know that the y-intercept's up at 10. That is as much as we could possibly know about that quadratic. We can't know any more than that. If, say, this was a negative 7.75, we could just carry on with decimals. It would have been absolutely fine. But this is an example of something that does not solve. Okay, so completing the square can have things that don't solve or things that do solve. Okay, moving on. This is more A-level-ish. Okay, it can be included within GCSE, but a lot of people won't have seen it. So we're going to complete the square and find the turning point of this. Now, to do this, we've got y equals, it is annoying that there is a 2 there. So what we do is we factor out the 2, and we factor it from just these terms here. So we have 2 lots of x squared plus 3x minus 13. You can, if you want to, factor it out of the negative 13 as well. It just makes extra work and puts extra risk into your work as well. So nobody really tends to do that. It'd be a bit annoying. So we get y equals 2, and we're going to complete the square in here. Complete the square in there. So we get 2 lots of x plus, I'll show you the decimal version this time because we didn't really get to see a solution with the decimal version on the previous slide. So we'll go 1.5 squared minus 2.25 minus 13 is still on there. Okay, be tidy with your work. Now, this is 2 lots of this entire square bracket. The most common error when completing the square is to expanding the 2 to be the coefficient to this bracket, but not expand the 2 in to multiply there. This is almost like a wink and smile question, okay? We must remember to multiply this coefficient by everything that's in these square brackets. It is the coefficient of the square bracket. It should multiply by everything in the square brackets. So we have 2 lots of x plus 1.5 all squared minus 4.5 minus 13. So y equals 2 lots of x plus 1.5 squared subtract 17.5. Okay, there we go. That there is the completed square form of this particular quadratic. Now, to get from that to your turning point, it's really easy. Ignore this 2. It doesn't really do anything with your turning point. That 2 almost sort of controls how squeezed together your graph is. So you could have, there's your turning point, for example. You could have a really squeezed together one like this, or you could have one that's not so squeezed together, or you could have one that is pretty squeezed together, where the turning point isn't affected by this 2 here. So your turning point is actually going to equal negative 1.5, negative 17.5. Okay. When your turning point is below the x-axis, which this one will be, it tells us that we have 2 solutions. If your turning point is above the x-axis, like one of the previous ones, it'll tell you that you've got no solutions, provided that this is a U-shape. Okay, if you've got a positive x squared and you've got a turning point that's positive, then inevitably you have something that looks like that. Okay, the solution for this is going to be a little bit awkward because 17.5 isn't a square number, and we're going to be trying to deal with that. It's going to be a little bit of an awkward one to deal with. So we'll have a look at how we can give the solution for this because it's going to be a bit of a strange one. Okay, we'll have y is equal to 0, pardon me. So we'll have 2 lots of x plus 1.5 all squared is equal to 17.5. X plus 1.5 all squared is going to equal 17.5 divided by 2. 17.5 divided by 2 is 35 over 4, which is 8.75. Should have known that one really. So 8.75. X will equal negative 1.5 plus or minus root of 8.75. Okay. Now, root of 8.75, it might well square root, but I'm not too sure whether it does, to be fair, into a nicer fraction. But that's what we've got. Your calculator will give you the nicer version, the nicest version possible of that if you deal with x equals negative 1.5 plus root of 8.75. Okay, so chuck that into your calculator. You'll get negative 1.5 plus root of 8.75, which comes out as something pretty horrible. We'll give it to 2 decimal places. 1.46. All right, and your next one will be the exact same except with a minus in it. Just go back and edit the formula. Okay, and 2 decimal places, we get negative 4.46. 4.46 when we used the minus version. Okay. It can be that when you've got a more complicated thing, decimals are just that little bit easier to deal with. Sometimes people like fractions, sometimes people like decimals. It's different things for different people. If you wanted to give the exact version, a nicer exact version of this, put it into your calculator and your calculator will sort it out for you. Okay, the sketch for this, we've got 1.46, we've got negative 4.46. If you add those up and you halve it, think about what you might get. All right, you get negative 1.5, wouldn't you? Which is why the turning point's at negative 1.5, which is halfway between those numbers. See there? That's negative 1.5, negative 1.5, and negative 17.5. Okay. Now the next question is nowhere near as difficult. It's just a little bit strange looking. Okay. We've got y is equal to, I want it to be just x squared. Doesn't matter the fact that it's negative, doesn't matter the fact that it's got a number in front of it. I just want it to be x squared no matter what. So I'm going to divide out negative 1. Lots of x squared minus 8x with a minus 2 on the end. I'm going to complete the square within those square brackets. So I'll get x minus 4 all squared minus 16 minus 2 on the end of it. Okay. I'm going to multiply in by that negative 1. So we get negative of x minus 4 all squared plus 16 and then the minus 2. So we get y equals negative of x minus 4 all squared plus 14. Plus 14. Okay. Okay. Easily enough, you should be able to spot the turning point. Have a look at it, see if you can figure it out. Well, the turning point is 4 and 14. As I said before, the number in front, the value there, doesn't matter. It's all about what these are. It's all about that. Okay, what that actually does is tells us that we don't have a U shape. We have, in this case, an N shape, quadratic. Where if this is 4 and 14, we know that because that's positive, we're going to get 2 solutions out of this. Okay, the solutions are when this equals 0. So we have negative x minus 4 all squared plus 14 equals 0. That's negative x minus 4 all squared equals negative 14. Cancel off the negatives and square root, and then add on the 4, and you'll get x equals 4 plus or minus root 14. Those will be your 2 solutions in exact values. You can also, if you want to, give the decimal version of those. Okay, if it helps you to do your sketch, that's absolutely fine. Okay, root 14 though is less than 4, and so it's not going to be a solution over on this side. It's going to be over on this side. So what I know is that I'll have my turning point, which was 414, and I'm going to have an N-shaped quadratic, also because the y-intercept's negative 2. Okay, I know that I'm going to get something that's going to look like that there. Okay, well this is 4 minus root 14, and this one is 4 plus root 14. All right, so here's an exam question. This exam question says find the values of the constants a, b, and c. I'd like you to pause the video and have a go at it. I'm going to give you about 3 or 4 seconds to just pause it, and then I'll get cracking and show you the solution. Okay. Hopefully you paused it and had a go and see if you got it right. So the first thing is that we've got 4x squared plus 8x plus 3. Don't worry about the y. Okay, the fact that it's not on there doesn't really affect you for this bit. It does affect you for that, but that's where it is. Okay, we're going to factor out the 4. Lots of x squared plus 2x plus 3. We're going to complete the square inside the bracket, so that's x plus 1 all squared minus 1 plus 3 on the end. And we're going to have 4 lots of x plus 1 all squared minus 4 plus 3. And so we get 4 lots of x plus 1 all squared minus 1. Okay, finding the values of constants a, b, and c. Well, a equals 4, b equals 1, and c equals negative 1. Try to make sure that you state those things. Okay, on the axes on page 27, obviously we don't have page 27, I'll just draw some. Sketch the curve with this equation. It's that one. Double check that it is the same one. So every so often they might give you 8x plus 16x plus 6 for some reason, showing clearly the coordinates of any points where the curve crosses the coordinate axes. It's not asking for the turning point, it's asking for the coordinate axes. That's not just the solutions on the x-axis, but it's also the solutions on the y-axis, the y-intercept as well. So let's go for solving it then. So we know that 4 lots of x plus 1 all squared minus 1 needs to equal 0. Okay, x plus 1 all squared, I'll move the 1, divide by the 4, I'll get 1/4. X plus 1 is going to equal the root of 1/4, which is plus or minus root of 1/4, which is a half, isn't it? So we'll get x equals negative 1 plus or minus a half. So x equals negative 1.5, negative 3/2, and x equals negative 1/2. Okay. So that's the plus version and the minus version sorted. My axes, they're not very good ones, but there we go. I've got them roughly proportionally correct. It doesn't mean it doesn't have to be perfect, but just a sketch is okay. So long as you've got these in the right order. So the one that's further negative is on the further negative side. That sort of stuff's really important. If you want to put the turning point on there, you can. The turning point will be at -1, -1. And we can pop on our quadratic, which will look a bit like that there, hopefully symmetrical. And we'll give our y-intercept. Now your y-intercept is found on the original quadratic. Always go back to the original quadratic to find it, which is 3. Okay, your y-intercept won't be -1. Don't get confused with that. That's your turning point, isn't it? But it's not asked for. So hopefully that helped. There's lots and lots of exam questions on this if you want to Google it. Thanks very much for watching. Visit numberclub.org to find out some more stuff. There's some more videos and tasks and things like that going on there. Please like the video and subscribe to the channel. Thanks very much.